So the next presenter I'd like to introduce is Pradeep Padala. Pradeep is from DOCOMO USA Labs. And working in collaboration with researchers at Purdue, Pradeep and his team have implemented GENI-VIOLIN. GENI-VIOLIN is a technique for snapshotting, migrating, and restoring not just individual virtual machines, but entire teams of collaborating VMs, along with their in-flight network traffic, all without missing a beat. Pradeep?
Thanks, Mark. Good morning, everyone. So the network architecture group at DOCOMO USA Labs, in collaboration with Purdue University, we are working on developing clean slate architectures, experimenting with network virtualization, especially with OpenFlow. Today in GENI-VIOLIN project, the question we are asking is how to deal with failures in large-scale infrastructures like GENI. The solution we are providing, the solution we are providing is in-network live snapshotting using OpenFlow. And the key feature it enables is good, fast recovery from failures, if there are failures in the large-scale infrastructures. So to start with, let me explain what snapshotting is. So most of you here are familiar with live migration of virtual machines. So here I'm showing a very simple example where we have 2 data center nodes, and there is a virtual machine running on node 1. Now, we can migrate the VM to another node, meaning that the running state of the virtual machine is moved to another node, and it is going to run on the second node. However, if there is a failure, then we won't be able to migrate the VM because the running state is lost. But what if we can store that running state onto disk? So that is what we are doing in GENI-VIOLIN. What we do is periodically snapshot the virtual machine onto reliable storage so that if there is a failure, then we can actually copy this snapshot, this picture we have taken, to another node and then restore it. So the key feature, again, that GENI-VIOLIN enables is recovery from failures. Now, I showed you snapshotting of one virtual machine, and it's easy. It's available commercially as well. But what about snapshotting multiple virtual machines talking to each other? They might be connected through one switch, multiple switches, or even more complicated is we have multiple sites, and we have virtual machines running on different sites talking to each other. There might be even a high latency link in between them. There might be multiple switches, heterogeneous switches and machines between them. The question we are asking in GENI-VIOLIN is, can we snapshot this entire slice? These are the slices that run on GENI, and can we snapshot the whole entire GENI slice? And if there is a failure, we want to recover the entire slice. So in short, what GENI-VIOLIN provides is live snapshotting of distributed slices, which run on GENI. I'm calling it live because the application is uninterrupted. I'm going to show that in the demo. Now, to get there, to implement this live snapshotting of the entire slices, there are many challenges that we need to solve. I'm going to talk about 2 key challenges. So the first challenge is that we want it to be live, meaning that no interruptions to the application or minimal interruption to the application. And we want to snapshot the entire distributed slice. And there is an algorithm for that, which was developed almost a decade ago, Matton's distributed snapshot algorithm. That is available, but we have to implement it. And the good folks at Purdue University have already done a good amount of work on that. It's called VMSnap. And they have implemented it using existing technology Zen and leveraging Zen's live migration. What we have done in GENI-VIOLIN is improve that snapshotting. And more importantly, we tried to move all the snapshotting functionality into the network. Why do we want to do that? Because we don't want to make modifications to the end host or minimal modifications to the end host so that we can snapshot any GENI slice even if the slice doesn't know that snapshotting is being done. So to do that, what we have done is add a few middle boxes, which we call as snapshot servers that store the snapshot. And then we have built a customized OpenFlow controller based on Knox that coordinates this distributed snapshot, in effect implementing the Matten's global snapshot algorithm. Now, I don't want to go into too many technical details, but I want to say that OpenFlow, the deep programmability of OpenFlow, is a key enabler for GENI-VIOLIN. So with that, I'm going to show today's live demonstration. Before that, I want to give a brief overview of what we are going to show. So we have two sites in our slice. We have the University of Utah and the GPO site. On the University of Utah side, we have a bunch of servers where we can run virtual machines. They're all connected to an OpenFlow switch, which is controlled by a customized OpenFlow controller. That's our GENI-VIOLIN controller that provides you the snapshotting capability. And now the middle boxes I talked about, snapshot servers, are going to store the snapshot so that if there are failures, then we can recover from them. Similar to University of Utah, we have another site, GPO on the East Coast, where it's almost the mirror image of the site at resources at Utah. These are connected through Internet to Link, which has relatively high latency. Now, what we are going to do is start an application on the University of Utah site, and then periodically snapshot that onto the snapshot servers in Utah. Now, if there is a failure, then we can actually recover from the failure by copying these files to another site. In this case, it will be GPO site. And if there is a failure, then we can copy it to the other site and then recover from there. Now, I want to show you this live. On the left screen, we have the GENI-VIOLIN dashboard, where all the commands for the snapshot restore can be executed. We just started the controller. This is our customized controller. And we are going to start virtual machines on University of Utah site. Now, on the right screen, we have the activity of all the GENI-VIOLIN system. Right now, nothing is going on. And here we have 4 nodes, A, B, C, and D. And we'll see activity on them in a second. And node E and F are acting as snapshot servers. When we take a snapshot, we'll see activity there. So now you see activity, the ants moving to the OpenFlow switch, meaning that the controller has set up the network paths. Now the VMs have started. We can start an application. The application I'm going to show is a distributed ray tracing application. We're going to connect to it in a second. The ray tracing application basically does a distributed ray tracing on 4 machines. One of the machines acts as the master node, and the other 3 machines are slave nodes. So you can see 3 parts of the image being drawn here by the 3 machines. One machine is acting as the master node. So this is a bonsai picture. It's being rendered live right now. And while it is running, we can take a snapshot of this. We want to take a snapshot so that we can recover from failures if they happen. Now, what's happening here is that when we take the snapshot, the running state of all the VMs is going to be copied to node E and F. So node E and F, we see small activity, and there is a spike in the network traffic, meaning that the image has been copied to node E and F, and it is stored on the disk. Now, once they are stored on the disk, we can copy them to any site in the slice, and if there is a failure, we can recover from them. I also want to point out that the application is still running with very small interruption. There is not even a blip, actually. Maybe a few 100 millisecond kind of interruption it happened. Now, after the snapshot is finished, we are going to copy the files to any site in the slice so that we can recover from failures. And we are going to use the Internet to Link, and the graph on top of it will show activity as we are copying the files. And you can see the spike and more. And so the file is being copied on this Internet to Link across the US to the East Coast. Now that the file is copied, now if there is any failure, we can recover from it. Well, we can cause hardware failure. We have a button for that. But in reality, we are actually yanking power off the VMs. So you can see on the right side that red blinking Utah site. Only the 4 VMs are gone. Utah site is fine. No need to worry. Rob, wherever you are, no need to worry. So now that the Utah site, or the 4 VMs on the Utah site are gone, we have lost our application, and all the rendering we have done is lost. In current scenario, in current state of the art, we can't do anything. We have to restart from the beginning. But we have GENI-VIOLIN now, so we can recover on the other side. So we choose the side GPO and click on Restore. As soon as we do that, on the GPO side, we'll see activity in a few seconds. Again, what's happening here is that we recover the running state of the VMs from the files and then copy them to all the machines, copy the memory image to all the machines, and then the controller sets up the path. After that, we unpause the VMs, meaning that we actually unpause all the VMs simultaneously so that the distributed nature of it is restored. The key aspect here is that this is consistent, and the application sees no difference. It will continue as if it was continuing on University of Utah. So it is restored. You can see the CPU activity there. And let's connect to it and see what it is doing. There it is. So the application we have restored, and it was at the point where we snapshotted it. I don't know whether you guys noticed, but it was at the point where we snapshotted it, and it will continue normally. Again, I want to point out that application does not know that this snapshot is being taken. It would continue as if it is on University of Utah. The IP addresses, the virtual network, everything is set up by GENI-VIOLIN. Now, that concludes our demo. And as the application is finishing up, I want to say a few closing thoughts about GENI and how we used GENI. We love GENI infrastructure, and I want to take this opportunity to thank everyone in GENI. They've been very helpful. And I want to point out that GENI has the unique features to make GENI-VIOLIN possible. There are 3 features that I want to highlight: the large-scale testbed, wide area network connecting like sites that are across the US, and the deep programmability of OpenFlow. This is the most important feature that we needed, and without that, GENI-VIOLIN wouldn't be possible. And we look forward to working with GENI. We're already working on better snapshotting implementation and maybe expand to more sites. We're also working on other projects dealing with in-network capabilities. I want to leave with one final sentence. GENI-VIOLIN provides live in-network snapshotting for GENI slices so that you can recover from failures. Thank you.